So here we are again with a build status update for the version 5 board. So this is the backplane board here, and this is going to be the new video generation board. So it's already partially populated. The soldering job from PCB Way is very neat, especially on this side here. Looks very good. I've already looked at it underneath the magnifying glass. So what I'm going to do now is that I'm going to populate this one so I can connect the memory board interface and the power. I may also populate these as well. This one here is needed because this is the reset line for the VSync, which goes back to the user port interface, and then this is used on the user port interface because it's the main memory bus, and then this is the expansion memory bus here. So these three at a minimum are needed just for the user port interface, which I'm not going to convert it to these yet. I'm going to keep it from the previous build because I know that that one's working. So I'm just going to populate this, but if I populate these as well, then in theory I can stack on the existing board. However, all of the existing boards are set up with a different number of pixel colors, whereas this board here has 16 colors per pixel with 16 palettes, whereas the previous revision was 8 colors per pixel with 32 palettes. So the different number of pixel colors come up here. I'm going to be using this one, a nice right-angled connector this time, and I've got a whole bunch of cables for inter-board connects, but I'm going to make this one up first. So one of the other changes was that this is now going to be a VGA output. There's also a debug header here if I want to populate this one. And I'm probably going to populate these variable resistors up here as well, just so I can tweak the video output colors. Now the main difference between this revision, of course, and the previous ones is that this is the backplane. Now these are proper sockets, and then we've got some proper plugs here, so I'm going to populate these two. So eventually what happens is that these slot in to the backplanes, or to the backplane here. Each board slots in like that. So it's going to be a lot more stable, no more through whole long pinned header connectors connecting everything together. Now time to start soldering. Build status update on the video board. So I've populated the pixel headers here and the memory selection edge pins here, and then I've populated the plugs here, and also the VGA connector and the variable resistors over here. I've populated enough of the clock logic so you can see that this IC here and this IC here have been seated in the crystal, and the resistors and the capacitor, and of course the jumper is set because I'm using the crystal rather than the oscillator that would normally sit within this socket here. And the logic analyzer is all set up to basically measure the hopefully 6 megahertz output signal. So I'm just going to trigger a capture here, and fantastic. So what you can see here is actually at the bottom of the screen here. You can see that I'm getting the expected 6.047930 hertz, 6 megahertz, so 6,047,930 hertz. roughly. So this tells me that at least the clock signals are working. All of the other connections here are actually drawing the 5 volts from the original user port interface board. So I'm kind of like just taking the power from there and then stuffing it into one of the unpopulated IC sockets for the moment. Now eventually the power is going to come in via these plugs here through the backplane, and then the next test is to pop this onto the backplane with the populated headers. But I'm going to do that later on. This is basically the smoke test. So this smoke test, this IC here needs its output enable pulled low, which is why we've got this wire here going to ground on another unpopulated IC socket here. And of course, because we're getting the clock crystal, then the jumper needs to be set as well. And this is a good smoke test because basically I can see that, as expected, I'm only looking for D0 here. D0 is connected to the clock output, and then D1 and D2 should be low and high respectively, which they are. And of course the frequency is still pretty much rock steady. So good progress. So far it means that I've not killed anything in the board with my frankly quite awful soldering skills. And now I'm going to populate the rest of the passives, so the rest of the resistors here, the resistor ladder, and then I'm going to populate the ICs and pop those into their sockets, and then I'm going to run a video output test with the video conversion box here just to test everything's fine. So short progress update. This is the old user port, Commodore 64 user port 224-bit address bus logic, and also the power input here. So this main header should drive power to this backplane here, and then you can see here that the video generation board kind of looks like that. I haven't quite finished populating the passives yet for the resistor ladders, and I haven't quite finished, obviously I haven't finished populating the ICs yet, but this kind of like gives a good indication about what this board looks like. So the VGA connector is up here on the top, and then all of the pixel header interconnects are going to go through here with cables that run along the top here, connecting into the various different layers here. So we've got video generation layer here, and then we've got plan sprites board, character screen, or character screen sprites, doesn't really matter, tiles, mode 7, APU, perhaps. Although the APU could sit on here with this interfacing into it, or this could just go onto the APU card. The mode 7 card is huge. Also there's an audio layer as well, which is also huge, so I don't know which one I'll build. The mode 7 one is actually not really used by the Shadow the Beast demo, so I might do the audio one, but we'll see how that goes. So I've tested the continuity without power from this header here, which gets its power from here. So testing continuity from plus 5 volts and then ground is top left, plus 5 volts is top right, and then I tested the continuity onto a few of the IC sockets here just to make sure that ground and 5 volts was coming through correctly, and it was. So now to power it up properly and then see if the logic analyzer still reads the correct clock timing from this. So here we are, back at the logic analyzer, and everything is switched off right about now. So I've switched it onto its side so I can more easily connect the 1 ground, and then the hopefully 6 megahertz ish clock. And then over here, of course, I've now used the header down here. This is the video header, debug kind of like video header, right? For the low display enable. So I'm pulling display enable under the underscore display enable low, and which will make this chip wake up and hopefully output the clock signal that's circulating around this area of the board here. So here's the logic analyzer. The important thing here is to watch the D0 frequency here when I switch it on. Hopefully no magic blue smoke comes out. And straight away, great, fantastic. And I think if I do an immediate trigger here, boink, yay! Look at that, we get a lovely clean clock signal coming from our logic analyzer, and it's captured a whole bunch of them. So that tells me that everything's good. So I'm going to now populate the rest of the resistor ladder passives here. These ones here, the final video output circuitry here, and then I'm just going to populate the rest of these ICs and then connect it all up to the video generation or video conversion box to see what kind of signal we're getting out of this thing. Now this won't have any graphics, of course. What I could do is I could use the previous boards, but again, like I said, they have the wrong number of pixels, bits for the pixels. They have, the old boards were using 8 bits per pixel. I'm now using the 16. Sorry, they were using 3 bits per pixel. I'm now using 4 bits per pixel with another 4 bits for the color palette information, as opposed to 3 bits and 5 bits. So the same number of colors in the palette in total, it's just that the color distribution is different, so we have an extra bit plane for each of the layers, so that we could get more colors per character or sprite or tile or whatever. So here we are, build update status. So I've fully populated now the video generation board. The only ones that I haven't soldered in are the RCA connectors up here, and that's because I'm using my new VGA connector up here instead, not even using this debug header, because I'm pretty sure that this works. I want to test this one. First switch on after doing an electrical test and populating all of the ICs and all of the resistors and everything else up here. So this is just the video generation board. There's no sprites board, there's no character board. This board here is only the user port interface board. Now, I'm not even going to connect up the Commodore 64 to this. All this is just basically to see if we get a good video signal on this video conversion box here. This is AV3. It should be getting RGB HV. I've not switched it on yet, so there's no sync. And then if everything works correctly, we should see on the screen here, we should see a nice, so kind of like a purple view or something like that. Purple seems to be the kind of default state of like the palette RAMs and everything. And because we've got no pixel information coming in, because there are no extra layers, then we should just see bright purple or something like that. Anyway, so let's switch it on. Let's focus on the video conversion box. Fantastic. And yes, we have a steady purple screen. And first things to note are that we've got good, very good, steady signal. The purple color seems to be very nice and consistent, considering the video generation here. So 15.74 kilohertz horizontal line rate, 59.63 hertz for the vertical refresh rate, and the RGB HV264, which is exactly what I'm expecting if I change the input to be RGBS. There you go. We've got a purple screen again, but this time the RGBS signal is generating 60.35 hertz at a 15.75 kilohertz line rate and 261p, which is exactly what I'm expecting, because that was exactly the behavior from the previous revision of the same hardware. This video tiles board has a dynamic, if necessary per pixel, layer priority register, which is really interesting to play with because I can change the priority of all of the layers on every single pixel if I want to, which lets me put sprites behind or in front of the characters, or in front or behind of the tiles, etc, etc. So yeah, cool, really excellent. So what I could do is I could connect up Commodore 64 now to this user port interface, and try programming things like the palette and stuff to make sure that the palette is fine. I might do that tomorrow because it's pretty late now, and I'm very happy with that initial test of this new video generation board. Fantastic, marvelous work, first time. So build status update for the new revision of the boards. This is the sprite board. It's not populated yet. I've just finished doing electrical continuity checks between all of the ground and the plus 5 volt pins on all of the ICs here. So everything looks good. The soldering job is as before, very nice and neat. These lovely connectors down here were evidently, they didn't have any problems soldering them in this time with the board edge, so now it's just a case of populating with all of the ICs and then plugging it in and seeing if it works, which I'm going to do now. Short status update with the build. So I'm about halfway through, I think, populating the board. It's getting quite late, so I'm going to stop now for the evening and continue on tomorrow. So I just did a very quick electrical test of the board in the backplane, just to make sure that the power supply still powers on and it still generates video signal, and it does. So at least that indicates that none of the chips are ran the wrong way. So continuing on tomorrow. Okay, so build status update. The board is all populated. The only small thing to note here is down here. So this IC was a little bit too long compared to the IC next to it, and because it's the back end to the back end, there wasn't enough room to push it in, so I had to put in another socket here just to raise it up enough to slot in, but everything else was perfectly fine. So all of the positionings and everything were great. So now it's time to test. So build status update. The sprite board is now fully populated, and I'm just about to test it with this code now. There's no other boards apart from the sprite board. So let's get this, go, and then we're seeing the exact same thing, which is fantastic. So the sprite board works. This is the sprite board with 16 color sprites rather than just 8 color sprites. So it works quite well. There was one small bodge needed, and that's to add a whole bunch of extra pull-up resistors to lower in parallel to the ones existing on the board, which lowers the overall resistance. This was needed because on this scan line here, which was the even scan line, it just wasn't correctly pulling up the resistance value. It wasn't pulling up the logic values from the scanline test. So we needed this kind of hack. It's a little bit of a unknown at the moment. I'm not entirely happy with the analog nature of having these pull up resistors inside the sprite logic. So actually the sprite logic which does that is here. I can show it on the screen. It was, if I zoom in a little bit on the schematic, it's these ones here. And actually I was able to reproduce the problem in the simulation as well. It was actually one of these resistors here, which was just causing some pain and suffering. So if I go to the schematic, it was actually I noticed that when I was seating the board, when I was twiddling the board, when I accidentally touched these, the sprite corruption went away, so I had to add extra ones. So debugging this is interesting. So I'm thinking about getting rid of the sprite pull-up analog logic here, and instead having some kind of proper arrangement. We'll see how it goes. So this is the old 8-color board stack back again, just for some debugging purposes. I've seated some of the new palette RAM chips here that arrived from Jamico. Those are Intel branded chips. They are not mysterious unbranded chips, and they seem to work. So, but at the moment, I'm actually just taking this video really to double check that this line here was going into the 6 megahertz, and I just verified that from an old video as well, where I managed to catch this in the video. But what I'm doing is that I'm actually debugging the quite noisy vertical pixel stripes that I'm seeing on the 16-color version of the boards here. I'm seeing if there's a regression, and there isn't. So I've actually connected one of the pixel, the first pixel header, one of the pixel lines, one of the palette lines, doesn't really matter, into 1H, which is here on the row column header. And as you can see, if I zoom in here, what should be nice and steady vertical lines aren't. And apart from the noise, which you can see, this blue here should be a constant color, I'm pretty sure, and this should also be a constant color. You can see that there's actually quite a lot of noise coming through. And if I go up here, you can also see the same kind of wibbly wobbly effect here. And you know, the palette colors are not so obvious here, and I guess the TV has some attempted noise reduction, but I can see with my eyes, it's not coming through so clearly on the video, but you can see some herringbone patterns here, or kind of like indicated very strange effects. Anyway, but I'm seeing similar effects on the 60-color boards, so it's definitely not a regression. There seems to be some very strange problem. You can see that the pixels aren't exactly formed up here either. And these pixels here are flashing a little bit here. The vertical strip here is not so precise, and here too you can see it's wibbly wobbling around a bit, but this one's the most obvious. Anyway, so yeah, interesting. It's interesting to note because this stack of boards here has a relatively short bus. You know, this 16 color board here has a relatively long bus. The row column signals come along, I think, on these bottom ones here, on these bottom connectors here, and they run across. And of course the other signals for the memory and stuff run across the top here. So this is the old board, not really showing much regression compared to the new board. So I'm chasing something which is apparent on both revisions. Great. And just a quick little follow-up. I've changed the position now because of the random-ish default random power on values for the palette names, right? So going with this palette that I can work with, because you know I don't have the memory. I don't have the user port interface plugged in. The user port interface is plugged into the new boards, and I don't really want to unplug that and plug it back in here and run a whole bunch of stuff. But I can do this okay with the default, not default, with the power on RAM state. So I've connected 1H now to a different pixel header. You can see if I zoom in here, I can see up here. If I hold the camera steady, you can see that the pixels are a bit indistinct, especially here, especially on this line. If I follow it down, this line here is misbehaving, this line here is misbehaving. 1, 2, 4, 1, 2, 3, 4, 5. So the pixels are not coming through that well. You can see that the TV is, or the video conversion box, or a combination of both. And you can see that it's still wibbly wobblying here too. So yes, and of course the eight color boards are actually quite noisy. It's interesting to note actually that the power supply is coming from here and going to here, and actually it's still powering the 16 color boards too. So actually the power supply is able, this is a useful test in itself, the power supply is apparently able to power both boards at the same time. Cool. But you can see here, if I zoom in here, you can see that this pixel line, so for example, is kind of bending in here. Here it's bending in. I don't know if this is a video conversion box issue or if it's a TV issue. I don't think it's a TV issue because I tried the other screen, and that was also with HDMI, and it was showing the same effect. Might be a video conversion box issue, might be noise, combination of all sorts of factors. It's annoying though. Without unplugging anything, the 8 color board here, 8 color boards are still plugged in, still powered. This is the 16 color board with the same 1H going to the pixel header arrangement. It's a different pixel header because in this version there is a pixel layer chooser. But anyway, it's very apparent with this power on palette. Luckily, you can see this really very strange effect, and this wave is for the whole screen horizontally, and it's for the top view character lines or whatever. It's for the top 32-ish pixels. Zooming out to the whole screen. It's 1, 2, 3, 4, 5, 6, 7, 8 approximately. The thing is that in between, if I come over here, in between the vertical lines here are actually quite stable. It's just here that it breaks down. Stable, breaks down. The stable portion is at a different position up at the top of the screen. It waves down here, bounces back, interesting. Not bounces back the full way, but bounces back a little bit, and then sticks down all the way down the screen. There's no other, there's no other weird effects really either. So it's all stable here. This is such a weird effect. I have a hunch that it's so apparent because there's a bright green palette entry and there's a black palette entry, and it's just very, very apparent with this power on palette. I think if I got a power on palette like that for the 8 color boards as well, I'd see a similar effect. Not forgetting that the 8 color boards were quite a bit more noisy. I noticed that when there's a consistent area of solid color on 16 color boards, actually it's less noisy. Ignoring the fact that I'm seeing this herringbone pattern. Weird. So it's interesting that it starts off here, and it kind of like starts off here, and it bounces, and it comes back. So the power here in Singapore is at 50 Hz, and this screen displaying rather is at 60 Hz. So I don't think it's mains interference. If it was, then there would be a 10 Hz difference, and I would see the effect scrolling up or down the screen or across. But it's not. Really very odd. It could be. Okay, so up at the top of the screen there's a little bit of V blank. There's V blank down at the bottom of the screen. The pixel output is disabled up here and around on the screen edges. As the screen starts to get displayed and the pixel output is turned on, maybe there is a significant power drain, and that power drain is showing itself as an analog effect. Maybe the video conversion box is trying to catch up to what the video signal is meant to be. I don't know, but it does look like an analog effect, but it's a very strange analog effect. But the analog effect for me is coming from this, and it bounces back a little bit, bounces back. So the analog effect might be, say for example, a power drain by the pixel headers, pixel values starting to really drain power or something, and the capacitors in board recover and then get stable because they're used to drawing more power or something like that. I don't know. Could be all sorts of stuff. But I don't think this is a... It's more apparent because I think the palette entries are showing it. But I don't think it's a regression per se from the 8 color boards. I think this just wasn't apparent before because the 8 color boards are a bit more noisy and I just wasn't seeing it perhaps. So I've set up the old board again, well not the old board, the new board, but without the character board. at the moment, so I just noticed as I set it back up again, things to note. The strange vertical line artifact here is still present in the tiles plane, okay, as expected, but also the transition from bright blue to dark colour for the sprite seems to be a lot better. There's none of that issue, and here too. There doesn't seem to be any of that weird fuzzing issue that I could see on the leading left hand side that was there before in both directions, or both flips. So one of these is flipped and the other one is not. I forget which one it is, but basically it's reusing the same animation frames, just flipping them horizontally in the X, which is really cool. But yeah, the fuzzing issue that was observed last time is not there. Might be a temperature issue, might be an issue that the board is no longer sitting on the transformer. That's certainly possible. But yeah, it seems to be a lot better now. Anyway, so now I'm going to start populating the character board because that's arrived. I just wanted to see this working again, set up back how it was. So build status update, I've just finished populating the characters board here with all of the ICs and all of the, I've just done a visual inspection and all of the orientations look correct. All of the legs have, all of the pins rather, have gone in to their sockets. There's nothing bent out of place or anything like that. So, actually I've just said that, I've just seen from this angle that this one's bent. I need to resocket it. Ha! Look, the benefit from looking at it on the phone. So, status update very quickly. I have finished populating the ICs. We can see here. I've been removing the ICs that I've populated as I've been going through the board, and the last ones were the large RAMs here and stuff, so everything's good. Using this code here, we can see that the character screen is working rather well. Now the sprites are appearing in front of the character screen because I'm using the default layer ordering right now. I'm not sending the different, and you can see here that there's the status update or whatever it is, the little health icons or whatever, spell icons or whatever, down at the bottom, and up at the top we have the lovely characters, and actually the quality looks really quite nice. Wow, look at that. Okay, that's really cool. And if I go up here, there we go, and marvelous. So yeah, that looks really cool. That looks really good. I'm now going to experiment to see if the character screen scrolling works. And a short progress update again. So what I've done now is that I've stopped the scroll in the tiles layer, which is the fancy background here. And I've basically, instead of using the tiles scroll registers, I've changed the code to just use the character screen scroll registers. And all that works rather nicely, as we can see here. So the character screen actually scrolls really quite nicely, and it seems to be quite nice and stable. I'm using the keyboard actually, X and V seem to map to the joystick quite well. And yeah, that's really quite working extremely well. Now the thing is, I've got a decision to make now. So what I did notice that actually for the character screen, I'm using just a small number of extra latches, and I retimed the character and the color data fetch. So when it goes into the parallel barrel shifters, if you like, which do the horizontal flip or the vertical flip, whichever one, horizontal flip, it's working off latched values, which actually seems to be a lot better for the character screen. If I move over here, it's actually, it seems to be a lot better in terms of quality. So I've got a decision now. Do I want to apply that same fix to the tiles screen and do another tile layer build and see if I can fix these lines in the tiles layer? Or do I, because the character screen actually, although it's smaller than the tile screen, I don't really care about the size so much as the quality of the graphics. And the quality of the graphics, actually, there are 4 times as many characters as there are tiles. And that's more useful to me because the tiles are 16 by 16 pixels and the characters are 8 by 8. And the 2 bits inside the color are actually used to index into the extra tiles. So there are characters. So there are actually 1024 characters. So I've got a decision. Do I just want to have multiple layers of character screens with scrolling and just get rid of the tiles? Because actually, if I look at the boards, this is the video board, this is the sprite board with its pull-up resistors up here, character screen board, tiles board. Tiles board is actually a little bit bigger because it's got some extra logic for the background pixel color here. And the characters board is actually a little bit simpler. So, I think I might just build a couple of extra character screen layers and remove the tile screen layer, and then basically live with the fact that I have a smaller virtual, smaller screen that can scroll around for the characters. It's 2 by 2 whole screens rather than 4 by 4 whole screens for the tiles layer. But the thing is that if I'm going to be updating the edges of the characters or the tiles at the edges of the screen and the top and bottom of the screen, while I'm doing scrolling, and I can update those, right, in the VBlank or whatever, as we would normally do, then I can have just full hardware scrolling while updating a virtual view inside this larger screen anyway. And that's perfectly doable. So I think I might just build extra layers of character boards and not really progress with the tiles for now, unless I really, really want to fix the tiles. But I'm really happy with how the characters screen has progressed, because the original Bomb Jack hardware, of course, only had 8 colors rather than 16 colors, and of course it didn't have any scrolling characters at all. So that looks really quite funky and really fantastic. I'm really pleased with that. Really, really, really pleased. Yeah, fantastic, excellent. Anyway, great. So success, build success. And now let's look at the boards. I mean, the boards are lovely. This backplane seems to work really well. I'm really happy with the backplane. The overall quality of the graphics is actually pretty darn good, right? Very nice indeed. Very happy with that. This new backplane seems to produce a much better video signal than the other one. And of course it's got twice as many colours. So success for this build. Fantastic. Okay, little update. So what I've done is that I've used a smaller 512 by 512 pixel background with the character screen. So the tiles are somewhere behind this. I'm not really interested to find out where they are. But you'll notice, look, even though the tile screen, even though the tile screen is using significantly different logic, and I thought that I'd fixed it, it's actually not. I'm getting this same effect that I'm seeing from that I saw on the tile screen with these colours here. And this tells me that actually the tile screen is not perhaps as bugged as I thought it was. Because these lines don't move with pixel position. Maybe it is related to the video board. In which case, I'm gonna just live with it for now. That's really odd. Okay, so maybe I will keep the tiles board. I don't know. I haven't decided yet. But anyway, it proves that the characters board really works very well. Nice scrolling, nice everything, right? Nice number of characters, fantastic, really lovely to see. I'm really happy with this. Now I think I'm gonna try building either the soundboard or the blitter. That copper, it's not really a blitter, although it does do fast memory access now, which can do fast copying. So it's a combination of blitter and copper. Anyway, so yeah, soundboard or blitter strip copper, the APU. Decisions. Now, I've got some plans for the soundboard. I was just thinking if I wanted to make it easier, I could have the base logic, a bit like the video board, and then add on for each voice an extra hat on top of the base logic board. So all of the voice logic state ICs and stuff could be appended onto the top, or actually onto the edge here of the soundboard, and it could build vertically or horizontally from a header using a common bus, which would reduce the complexity, and actually it would make it possible to expand the audio hardware from 1 channel to 2 to 3 to 4 very easily and cost effectively. So maybe I'll do that. Anyway, I'm really quite chuffed.